In this section, we're looking to solve exponential and logarithmic equations. So those are equations that have a exponential term or a logarithmic term. So whenever we solve an equation, our goal is to get the variable by itself, or in other words, solve for the unknown, which in our case, we're just going to use x. So we have a couple types of exponential equations. The first type, our goal is to write both sides of the equation with the same base. And then we set the exponents equal. And we can do this because we have a property that says that if a to the x equals a to the y, so we have the same base but different exponents, that implies that the exponents are equal. Let's take this one for example. 6 to the x minus 2 equals 216. 6, we can't really write that with any other base, so we're just going to leave that as 6 to the x minus 2. Now what about 216? We want to write 216 equal to something with 6 as a base. So what exponent do we have to put on 6? Well, 36 times 6 is 216. So that means that 6 to the third equals 216. So we can replace 216 with 6 to the third. All right, we now have the same base on both sides, so we can set the exponents equal. We get x minus 2 equals 3. Add 2 to both sides, and we get x equals 5. Let's look at this one. 7 to the 2x equals 49. We're going to leave 7 to the 2x, but rewrite 49 as something with a base of 7. Well, we know that 49 is 7 squared, so we can rewrite 49 as 7 squared. So 7 to the 2x equals 7 to the 2. Now we can just set those exponents equal. We get 2x equal to 2, divide both sides by 2. We get x equals 1. Now let's look at the second type of exponential equations. These are ones that we're not going to be able to rewrite both sides with the same base. So the first thing that we do is isolate the exponential term. So looking at that first example, if we isolate the exponential term, we need to divide both sides by 5. So if we divide both sides by 5, we're going to end up with e to the x equals 12. All right. So e to the x equals 12. I'm just going to rewrite that. So we did this. Now the next step says take the log of both sides. That comes from applying this property. Log base a of something with that same base, a to the k, says that the result is equal to just that exponent. The reason that this works is because, let's just take a moment and rewrite that log expression in exponential form. So first of all, taking the base from the log, that's the a, and then applying the k, which is the exponent, all right? Well, that's equal to what we have in red there, which is a to the k. Okay, so we can see if we take the log base a of a to the k, it just gives us the exponent. All right, let's go back to our problem there where we want to take the log of both sides. We want to take a log that's going to have the same base as that has the variable in the exponent, so we can get that variable out of the exponent. So let's take the natural log because that has the base of e. So natural log e to the x, natural log 12. So as long as we do the same thing to both sides, this keeps this equation. So natural log e to the x, so remember that natural log is log base e of e to the x. So based on that property we have just right above it, that's going to give us just the exponent x. And that's equal to the natural log 12. All right, plugging that into our calculator, we can round to 3 decimal places and get 2.485. Let's look at this example. 10x equals 2 to the negative x plus 4. All right, we've got an exponential term on both sides. and we want to get x out of the exponent, so that means we're going to be taking the log of both sides. We can't do any more isolating because we have an exponential term on both sides of the exponent, so that takes care of step 1 above. So step 2 is we're going to take the log of both sides. So since we have a base 10, we can use the common log and then eventually plug that into our calculator. So let's take the common log of both sides. So we're going to take log of 10 to the x, and then also common log of 2 to the negative x plus 4. Okay, so on the left, we're taking it's log base 10, remember, because it's the common log. So that means what we are left with is just the x. So we have x equals, but because this is log base 10 and then it's 2 to an exponent, this stays just as common log of 2 to the negative x plus 4. Okay, so here we need another property to help us out. All right, the property says that if what we're taking the log of has an exponent, we can bring that exponent out in front of the log. So if we apply that to our problem, we can say that x is equal to, and we're going to bring this exponent, negative x plus 4, out in front of the log, negative x plus 4. And it's a quantity, so let's put it in parentheses, and then that's times common log of 2. Now keep in mind, common log of 2, this is just a number. We can plug that into the calculator and get a value. We're not going to do that yet because we want to solve for x. X shows up 2 times. We're going to want to get x by itself. X is trapped inside those parentheses. So we're going to need to distribute log of 2. All right, so we get x equals, and then negative x times log 2, so negative x log 2, and then 4 log 2, after we distribute that log 2. Now, x's show up on 2 sides of the equal sign. Let's move the negative x log 2 term to the other side by adding it. And we're almost there. X shows up twice. So if we want x to show up 1 time, we're going to factor it out. Well, if we take x out of x, we get 1. If we take x out of x log 2, we're left with log 2. And the other side is still 4 log 2. All right, now to get x by itself, we are just going to divide both sides by 1 plus log 2. All right, so on the left, 1 plus log 2 is going to cancel top and bottom, and we will be left with x equals 4 log 2 over 1 plus log 2, and I'm seeing I left off the 2 here. All right, because we have common logs, we can plug this into the calculator. All right, it is equal to, rounding to 3 decimal places, 0.926. Okay, here's another example. We've got 2 exponential terms. They are isolated on either side of the equal sign. So we want to take the log of both sides. Neither of them are a natural log or a common log, so we can choose what to use. We want to use either a natural log or common log. Either one will work. Let's use natural log. So we're going to take the natural log of 3 to the negative 2x minus 1 and take the natural log of 2 to the x. Okay, so we want to use that property again where if we take the log of something that has an exponent, the exponent can come out in front. So this is, on the left, we're going to have the quantity 2x minus 1, negative 2x minus 1, the exponent, out in front of the natural log of 3. That's going to be equal to, take the exponent of x, bring that out in front of the natural log of 2. Okay. All right, keep in mind natural log 3 and natural log 2, those are just numbers. We want to get x by itself. Right now it's in 2 different places, right? It's here and it's here. So if we want to get it by itself, we first have to get it outside of the parentheses on the left. So we're going to distribute that's going to give us negative 2x natural log 3 minus natural log 3. And then that's equal x natural log 2. All right, so again, we got x here, x here. We need to get those terms both on the same side. So if we subtract x natural log 2 from both sides, we'll get negative 2x natural log 3 minus x natural log 2. And while we're at it, let's add natural log 3 to both sides. So that gets the term without x on the other side. X is here, x is here. We can factor out the x, and we'll be left with negative 2 natural log 3 minus natural log 2. Now x shows up just one time, so to get it by itself, we want to divide by negative 2 natural log 3 minus natural log 2 on both sides. And that's going to get us x by itself. So we get x equals natural log 3 over negative 2 natural log 3 minus natural log 2. And plugging that into the calculator, we get negative 0.380. Okay, let's look at this example. We want to get the exponential term by itself. So we subtract 6 from both sides. We get 4 e to the x equals 16. Then divide both sides by 4, so we get e to the x equals 4. This one we only have one exponential, and we can take the natural log of both sides. And the natural log of e to the x results in just x. That natural log has base e, and so it sort of undoes having that base e of what it's taking the natural log. So we get x equals natural log 4. And we get 1.386 from the calculator. Let's look at this exponential equation. First of all, get that exponential term all by itself. So add 2 to both sides. So e to the x squared minus 1 equals 5. And now let's take the natural log of both sides. Natural log e to the x squared minus 1 equals natural log 5. So on the left, we're going to be left with just the exponent. The natural log undoes that base of e, so we are left with just the exponent, x squared minus 1 equals natural log 5. So now we solve for x, add 1 to both sides. X squared equals natural log 5 plus 1. Take the square root of, take the square root of both sides. So we get x equals plus or minus square root natural log 5 plus 1.